Okay, so I will give a short intro about Kubebuilder. It's a framework for building Kubernetes operators to extend its API. Uh, it's using Go as language, but there are existing similar libraries for different languages. So I will start shortly with Kubernetes API. Uh, Most of the API is exposed via various objects. These objects are stored in API server, and there is basically behind the scenes components which look into API server and do something about it, like schedule pods and so on. Each object has quite important properties from point of view operators, which is version and kind, which is unique identification of each object, name, which is something human readable, and ID, which is usually just generated UID. Objects have internally dependencies between them, so you have like owners and dependence objects, so you can basically work in API with things like kill all dependents of this object or list it by some state and so on. Another feature of objects quite often used in operators is labels and annotations. Labels are basically key values pairs, and you can vary API based on the labels. Annotations are quite similar, but they are not searchable by. You need to explicitly look into object and list all its annotations. And also it has advantage that annotations doesn't change object lifecycle. So operators could use it as some storage for data or storing some state or behavior. Finalizers are basically identification of operators or tools running in the cluster, and it allow some components to announce Kubernetes that when some object is being deleted, that this something else needs to be done, like garbage collection. So all basically all code in Kubernetes could add itself to any object as finalizer, and then watch when the object is being deleted, and when everything is done, then each operator remove itself from finalizers. And last thing is not directly stored in objects, but it's events, and it's attached to object usually, and it's basically communication to outside world that something happened, and in events there is stored what happened and what, for example, what was result and who initiated. Yeah, start. Yeah, yeah, lepší. So for to have place where to put this, or every operator needs some configuration. It's stored as usually as a separate object in Kubernetes, and there are two things. One is custom resource definition. It's like JSON schema of the object itself, and custom resource, which is something like pod, and it's instantiation of some instance of this custom resource. Both these definitions are, or custom resource definitions are cluster scope, so they need to be installed for whole cluster, and custom resources are could be namespaced or cluster scope based on their usage. So the operator pattern is basically or operator runs as classical application. It can run either inside the cluster as pod. It can also runs outside of the cluster and just use API, but most usually it's the first option, because then it has access to some more APIs than when you are able to access from outside. The operator watches for either state of its own custom resources, or it watches over state of objects or events on these objects, and it try to make sure that what is written in the custom resource is actually applied on the cluster. So example, number of pods which should be running for application and so on. So it's basically all the time aligning definition with actual state. The operators themselves could be written in any language. The Kubebuilder is specifically built by Kubernetes team and it's use Go, but there are similar projects in Java and probably in other languages, but usually they are lacking in features and they are catching up the Kubebuilder implementation. So Kubebuilder is set of tools. It's mostly done in a way that it generates part of the Go code and so you can easily create own custom resources because it's usually quite a lot of code. So the scaffolding to create base skeleton of the application with my files, with base structure and so on. It's also a set of libraries. So when you need to access those common things in cluster, there is usually some helpers for it. And main thing is that it's generate basically skeleton for the controller. So when you write operator, you don't need to care about how to run it, how to deploy it, because everything is generated and the there is a Go file which just needs to be fit in with the logic of the controller. You basically get it's event-based loop, so you just receive that name of the object and you just decide what to do with it. You just get notification that this object changed and you have to go to API, look what actually changed and what you should do about it. Together with this, it provides also tools for testing. So there is some mock of Kubernetes API and also helpers how to build and deploy the operator, custom resources, and so on. And last thing, which is quite important, is that it also provides caching of the all state in Kubernetes. So you don't have to every time talk to API and list a whole cluster because it will cache most of the things for you. There will be at the end link for the documentation. The documentation is done in form of book and it has quite extensive sample application where you can write custom cron job. This is how it looks like in the from Go point of view. There is a process where you write which runs manager, and manager basically have Kubernetes client, which is classical Go client for Kubernetes, have cache for everything which is accessed. And then there are two parts. One, the controller on the left is basically where you place your logic. You receive event, this object changed, and you basically need to do something. Use API, use all tools. It will provide you to find out if the real state match the what is in the what happened in the event. Another part is on the right is it provides some scaffolding for creating webhooks because Kubernetes allows you to register yourself and you can then modify, for example, all objects which are being created or changed. You every time get info about the change and you can change object somehow. It's quite often used, for example, for injection of the sidecars and so on. When to use Kubebuilder is there is already a lot of operators. Most of them actually use Kubebuilder inside. So best is to look if someone already did something like that, what you need, and if you then don't write your own code. Some simple things could be done by some few charts and scripts. So there are some simple reactions to event could be implemented like Argo events and so on. So if it's just like expansion of some configs, then it's not need to write operator for it. And so most of the time it's best when there is like when you have some complex system and you want to make it easier for the users. So you just create some CRD, and when someone create this CRD with values, you just go and create pods and all things basically which are needed by the service. And it doesn't have to be online Kubernetes. The operator can, for example, in cloud environments, create extra database in cloud and then just put in secrets, credentials, URL, and so on. And for when you do something manually in clusters while maintaining applications, then it's probably quite often good place to automate it or make operator as part of the reaction to the alerts. So sometimes there could be, when you have clear runbooks what to do, you can then just react to webhooks and solve alerts automatically by operator. Uh, when not to use it is basically opposite of all previous steps, and one is quite that most often it's not problem to write operator itself, but to define how to do it and to think out all conditions. So sometimes it could be quite complex, and not everything is solvable by automation. So it's to be thankful if it's worth to actually automating it. Some best practices for writing operators is just its normal Go code. So use everything what is available for Go. It's normal application. So unit testing, linters, code coverage, and so on. It's also good every time good to use role-based access control in Kubernetes. So the operator has just narrow set as possible of rights what to do. There is support for versioning, so use it. Do validation of the custom resource objects, so user cannot enter but CRDs. And most important thing is to let users and outside world to know what actually operator is doing, because usually users don't look into logs of operator. So that's why there are events on the object. So you can clearly put event on every object operator run and decide not basically do this thing or do nothing, and so on. And for testing, it's best to use some lightweight Kubernetes cluster-like kind, so you can have integration tests when you actually spin up your cluster in kind and test all cases, and then just shut it down. All actions in what operator do should be idempotent, because there is usually more operators, or more operators could be interested in same object, so they can changing the object simultaneously. So it's good that all changes in the object structure is every time idempotent, because you can get the object multiple times and you need to decide if object is already modified or not. And also the sources doesn't have to be every time from API server, but you can use basically metrics or anything outside of the cluster itself. There are some advanced concepts which are more in detail described in the book, but it's the finalizers I was mentioning, versioning and automatic conversion between various versions of the object. There are basically also possibility to run operator as scheduler, so it wake up every some time and do check this if the state really match still the desired state. And there's possibility for webhooks which Kubernetes will call you, and you can decide what to do with the object you received, like modify it, validate it, or mutate it to something else. This is also quite dangerous because you cannot really do anything with it. So you can even delete it. So there are a few things which you should care of because when you implement the reconcile loop, the object usually you will usually receive the object multiple times. So you need to really know at what stage of the object creation you should react, because usually, for example, when object is created, you will get it in the loop like 4 or 5 times. So even in the empty cluster, so you really need to watch on all properties, and based on the properties, you decide if object is already in state when you want to modify it. Because, for example, when the object is deleted, there is just appended deletion timestamp in the properties, and it's everything. So you need to just look if this property is there, and if it's appear, that you know that someone is deleting the object, and you should do all cleanup. Sometimes problem is with security because some operators need to be running on the cluster level. So, for example, the mutating webhooks actually could modify whole cluster. So you need to test your code quite well. And the book is still not all concepts are written there. So sometimes you need to just look into the code and, for example, look for all options, because the documentation and book has most basic or just the most common use cases, but sometimes you will find more options if you look into the source code, but it's quite well documented and written. There is some examples of the operators. For example, Prometheus operator is quite common, which already exists, and Cassandra or most of these technologies has currently some Kubernetes operator with them. And these are use cases we actually used. So you can use operator for modifying pods, injecting sidecars, or make something like bridge to external world. So you can basically let customers use all clients of the cluster, create some customer resource, and you can go to like database, create accounts there, and return them secret or create secret in the namespace back. So the user doesn't have to know that there is the thing is actually outside of the Kubernetes, and can configure it in same way as the application. It's also possible to do. There are already some autoscalers, but if you need some more complex conditions, then you can write operator which will watch metrics, watch cluster state, and decide based on more complex things like just some value to if the component should be scaled up or down. It could be used for handling alerts. So some could like there is not enough space, then you can just go look for history of disk usage and then decide to increase it or not. And quite common, some components are in some middle state. They are working but not so healthy. So it's usually quite complex logic to detect that. And operators is one use case, or it's one use case for using operators to just look on all conditions. And if there are some problems, then in some manner to restart, for example, pods. There are then links to the basically the GitHub book and GitHub of the Kubebuilder itself. And it's all if you don't
Okay,
have questions.
it was some questions for you.
Only question, what do you mean by running in scheduling? Because if I recall correctly, if you define a Kubernetes controller, there is a sync period, which basically means how often fake event will be created for you that something changed, but change not is in the cluster. So you are not getting in the wrong states. So what's the usage for scheduled run?
It's, for example, when you have also some external components and you want to check that all state is actually as you want. So I don't know, we use, for example, this when there are some problem with the Kubernetes nodes themselves, then you can actually pod could be unhealthy, but you will not get notified because but you can actually ask the pod directly over some endpoint, and then you will notice, you will be able to detect it. but it's also implemented in the control loop you just return. You want to be notified again in, I don't know, 15 minutes, and then the Kubebuilder will take care of it.
Okay, thank you.
Thanks for talk.